Good morning. Lesson 9-2, surface area of a rectangular prism. So what's a rectangular prism? Well, you know what a rectangle is. A rectangular prism is a 3D rectangle, so it's basically a box. So it has a front and a back, and then it has a top and a bottom, and it has 2 sides. So it has 6 sides. And if you want to draw what's called a net, this is what a net looks like. So a net basically is if you cut it out and fold it on all the lines, you could fold it up and make the shape that you're looking for. In this case, a rectangular prism or a box. All prisms are sort of the same. You could have a triangular prism where you have a triangle face or a triangular base, they will call it, and then off of the triangle you would have sides that meet the base at 90 degrees. And you got to remember that because it's a triangle, right, it would have 3 sides instead of the 4 sides that a rectangular prism has, because a rectangle has 4 sides, and then when you come off of that, you'd have the other sides. Let me get you a 3D model. Hold on. So a rectangular solid would have a rectangle as its base, and then to make it a rectangular solid or a prism, the rectangle is the base and it sits on the base, and you have a matching top, but then the sides all meet the base at 90 degrees, so they just come straight up. And then you could find the volume, remember, length times width times height. Or like we're going to do today, we're going to find the surface area. So you're going to find the area of all the surfaces. So these 2 sides, the front and the back, the bottom or the base, and the top. And they match. So that's a rectangular solid. This is also a rectangular solid, even though it has a square as a base, because a square is just a special rectangle. Same as this is also a rectangular prism, but it's a special kind because the height is the same dimensions or measurements as the length and the width. And so we'd call this a cube. Sometimes your base could be a different shape, like the triangular prism. So its base is a triangle, and then the height comes off of the base at 90 degrees. And so that's what a triangular prism looks like. You could also have things like a hexagonal prism. So a hexagon as the base, and then the sides again come up at 90 degrees. And you have a hexagonal prism, a special one. We don't call these a circular prism. We call these a cylinder. So if the base and the top are circles, but the sides meet at 90 degrees, that's a cylinder. A special one that's not a prism would be, I would call this a cone. It has a circle base just like our cylinder, but the tops do not come up at 90 degrees. They come up to a singular point above the center. And so that's a cone. You can think of a cone like where you put ice cream, or maybe a snow cone. This is not a rectangular prism because though it has a rectangle as a base, again, the sides are not coming up at 90 degrees, right? See how they don't come up at 90 degrees? That makes this a pyramid. This is a square base pyramid. And this is a pyramid that has a triangle as a base. So it's a triangular pyramid, and it has therefore only 3 sides versus the 4 sides. Today, though, we're just going to work with rectangular prisms. Let's just scooch those right out of the way. So anyway, you build a net. And then to find the surface area, you find the area of all the surfaces and add them up. So if we took this shape, we're going to have 2 that are 2 by 3, 2 faces that are 2 by 3. So a 2 by 3 and a 2 by 3. This is 3, 3, 3, 3, 3. Labeling all of them gets a little tedious, but that would be the front face and the back face. And then we have sides that are 4 inches long by 2 inches tall. So 2 inches tall, 4 inches wide. So we have the back and the front. And then the top and the bottom are 3 inches by 4 inches. So 4 inches by 3 inches, 4 inches by 3 inches. So you just find the area of all those. So let's do that. What's 2 times 3? 6. What's 2 times 4? 8. 3, so this side's 3, and this side's 4, and 3 times 4 is 12. 2 times 4 is 8. 2 times 3 is 6. And 3 times 4 is 12. And then you add them all up. 12, 12, 8, 8, 6, and 6. And 12 and 8 make a 20. And a 12, that's a 0 by the way. 20 and 20 is 40. 52. And then we can look at our units. Inches. And we times, remember we times to get the 12. Inches times inches. And inches times inches is written as inches squared. So the surface area for this rectangular prism is 52 inches squared. All the sides, you find the area of all the sides and add them all up. So let's do this one. So they'll give you, sometimes they'll give you graph paper, or you might have some graph paper, or your school might have some graph paper, and you could draw out the net. And being able to draw the net is a really good activity. So let's do, it's hard to try to imagine how it could fit. I'm going to do 7 inches, and this one's going to lay out 3 inches. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. And my first, this face is going to be 7 by 3. So if I laid this down, kind of like, I don't have a good shape for it, kind of this one. I'm thinking that it's going to lay like that. So I want this side to be the 7. And then I need this, 1, 2, 3, to be that side. Okay. And then this is going to be attached, and it's going to be 3 inches. 1, 2, 3. 2 little marks like that means inches, if you can't remember that part. Okay, and these are 3 inches as well. And then they need to go over 4 inches. 1, 2, 3, 4. 1, 2, 3, 4. And that would be those short little sections. And then they're connected by a 7-inch long one, because that's the height. This is the base and the top side. Another side. And then we need 3 inches. And then we're going to need another 4-inch one. And that would be the net. Oh, I should probably connect this part. That would be the net for this particular prism. And then we could find the areas. 3 times 7, 3 times 4, 3 times 4, 4 times 7, 7 times 3, and 7 times 4. And then we could add those all up. 2 at 28, right? Check, check. 2 at 21, and a 12 and a 12. 8, 16, 17, 18, 19, 20, 21, 22. 2, 4, 6, 8, 10, 12. 122 inches squared is the surface area. Okay? That's the basic part of surface area, but of course we've also got to be able to go backwards, because what if they give us the surface area? Oh, maybe we don't have to do that one today. Let me double check. Oh, nope, so far we don't have to go backwards. Well, that's a bonus, everybody. Let's try this one. So this is more of a real life skill, because someday you may actually want to paint or put siding on something, and you don't usually put siding on the doors. So you have to remove the doors from the calculation. So Mrs. Hernandez is redesigning her craft room, which is in the shape of a rectangular prism. She wants to add a wainscoting, which is a wood wall covering. Did it say it was ceiling? Nope. Did it say it was floor? Nope. So we don't have to deal with the wall and the floor and the ceiling. From the floor, halfway up the walls. Well, let's figure out how far halfway up the walls are. Looks like this is the wall height, and the height is 8 feet. So what's halfway? Yeah, halfway would be 4, because 4 plus 4 would be 8, right? So she's only going to put wainscoting. In case you didn't know, wainscoting is like beadboard, and it has these little marks that go down it. Only wants to go halfway up. And then it says there are 2 doors that are each 3 feet wide, and we're not going to put wainscoting on those, right? So it would come here, then skip the door over. So we only need that. So we need to find the surface area for that, because that's how many square feet. So here's what you do. Find the perimeter. So we've got 12 plus 9. Plus this side would be 12 because it's opposite of that. And this side would be 9 because it's opposite of that. And then we can times it by the height we need. Do we need all 8 feet? No. Oh, I forgot something. We got to subtract something. And then we can take all of that and times it by the 4 feet that is our height. What did I forget that we have to subtract? That's right, the doors. Miss D, you can't do the doors. And we have 2 of them. 2, that's a subtraction sign, by the way. 2 of them that are 3 feet each, right? So we're going to end up with 6 away from 12, and 9 is 21. And 21, 2 of those is 42. What's 42 minus 6? Did you get 36? I feel like I got 36. And then we're left with 36 times 4, which is 144 square feet. Okay, so the area she's going to need is 144 square feet of wainscoting. And that's how then you could go to the store and you could buy it. A store, you know, like Home Depot or Tumalum. Okay, that should get you through the lesson. Good luck.